What if I told you a Mexican mechanic built a Volkswagen Beetle engine that made 200 horsepower, not with turbos, not with nitrous, naturally aspirated, from an air-cooled flat 4 that Volkswagen swore couldn't reliably make more than 50? This is the story of Carlos Gonzalez, the VW dealer mechanic who proved Germany's finest engineers wrong and created one of the most legendary sleeper engines in automotive history. Mexico City, Saturday afternoon, June 15, 1968. The sun is beating down on the Autodromo drag strip, and the air smells like burnt rubber and high-octane fuel. The staging lanes are packed with American muscle. Camaros, Mustangs, Chargers. Big blocks rumbling, shaking the ground, making that deep V8 thunder that lets everyone know serious horsepower is about to throw down. And then, rolling up to the staging lanes, comes a bright yellow Volkswagen Beetle. Stock-looking, tiny, almost cute. The crowd? They laugh. I mean, can you blame them? Stock Beetles run 18-second quarter miles on a good day. These are the grocery getters, the economy cars, the vehicles your grandmother drives to church on Sunday. They make 57 horsepower. 57. A lawnmower has more punch. The guy in the Camaro next to it is grinning, shaking his head. This is going to be embarrassing. The starter walks up. The tree counts down. Amber, 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 green. And that's when everything changed. That little yellow Beetle doesn't just launch. It explodes off the line. The front wheels lift. Actually lift off the ground. The crowd goes from laughing to silent in half a second. The Beetle is moving. Not puttering. Not struggling. It's screaming down the strip like it's been possessed. The tatch is buried. The exhaust note isn't that cute little put-put-put. It's an angry, mechanical shriek that sounds like something's been woken up that shouldn't exist. 12.8 seconds later, it crosses the finish line at 108 miles per hour. The Camaro? Still hasn't finished. The crowd is dead silent. That's not possible. That's physically impossible for a Beetle. The spectators are looking at each other, wondering if they just saw what they think they saw. The tech inspectors are already walking over, because something has to be wrong here. This has to be a cheat. But Carlos Gonzalez just made it happen. And he's sitting in that driver's seat with the biggest smile you've ever seen, because he knew this was coming. He'd spent 3 years making sure this moment would arrive. 3 years of being told, that's impossible. 3 years of Volkswagen's engineers laughing at him, dismissing him, treating him like he didn't understand basic thermodynamics. And now? Now he just humiliated every single one of them in front of hundreds of people. But here's what makes this story even crazier. That wasn't even his fastest car. That was just the beginning. The proof of concept. The warning shot. Because what Carlos Gonzalez discovered in his small Mexico City workshop was something Volkswagen's billion-dollar engineering department in Germany had completely missed. He found potential in an engine they'd written off as maxed out. And he was about to turn the entire VW performance world upside down. But to understand how a dealer mechanic outsmarted an entire company of German engineers, we need to go back. Back to what Volkswagen said was possible. And more importantly, what they swore was impossible. The factory limitations and the rebel. Stuttgart, Germany, 1938. Ferdinand Porsche sits at his drawing board, sketching what would become one of the most iconic engines in automotive history. The Volkswagen Beetle's air-cooled flat 4. His mission? Create an engine so simple, so reliable, so cheap to produce that every German family could afford one. And he succeeded. By 1968, 30 years later, that little engine had conquered the world. It powered millions of Beetles across every continent. It was bulletproof, easy to fix, and required almost no maintenance. But powerful? The largest factory version in 1968 displaced 1,600 cubic centimeters and produced a modest 57 horsepower. That's it. 57. And Volkswagen's engineers in Wolfsburg had calculated the absolute limits of their design with German precision. They published technical bulletins. They wrote engineering papers. They made it crystal clear, the magnesium crankcase cannot handle more than 1,800 cubic centimeters without cracking under stress. The cooling fins cannot dissipate heat from more than 100 horsepower. Push beyond those limits and you won't have an engine anymore. You'll have molten aluminum where your pistons used to be. Catastrophic failure. Complete destruction. This wasn't opinion. This was science. Mathematics. Thermodynamics. The laws of physics themselves. At least, that's what they told everyone. And the entire automotive world believed them. Why wouldn't they? These were Volkswagen's own engineers. The people who designed the engine. They knew every bolt, every tolerance, every material property. If they said 100 horsepower was the maximum, then 100 horsepower was the maximum. End of discussion. But 2,000 miles away in Mexico City, a senior mechanic at Volkswagen de Mexico's main dealership wasn't buying it. His name was Carlos Gonzalez. By day, he wore the clean VW dealership uniform. He serviced Beetles for middle-class families. Oil changes, tune-ups, brake jobs, the routine work that pays the bills. But by night, Carlos transformed into something else entirely. He'd spread engine blueprints across his kitchen table. He'd measure every component of Ferdinand Porsche's design with calipers and micrometers. He was looking for something. Hidden potential. Design margins. Conservative engineering buffers. The gaps between what Volkswagen said was possible and what actually was possible. Because Carlos had been racing Beetles since 1965, and he'd grown frustrated. Deeply frustrated. While American muscle cars were pushing 400, 500, even 600 horsepower from their big blocks, the best VW engine builders in the world were struggling to extract 80 horsepower from their tiny flat fours. That was considered exceptional. Legendary even. The conventional wisdom among VW tuners was carved in stone. You could bore the cylinders slightly. From 85.5 millimeters to maybe 88. That would take displacement from 1,600 cubic centimeters to about 1,700 cubic centimeters. You could port and polish the heads for better airflow. Install a hotter camshaft. Add dual carburetors instead of the single stock unit. If you did everything right, if you were really good, you might see 75 or 80 horsepower. Maybe. And that was it. That was the ceiling. Try anything more aggressive, and the engine would overheat within minutes. The cylinder head temperature would spike past 400 degrees Fahrenheit. The exhaust valves would glow cherry red in the dark. The pistons would seize. The engine would destroy itself. Everyone knew this. Every VW tuner had seen it happen. Except Carlos Gonzalez noticed something while rebuilding hundreds of these engines. Something nobody else was paying attention to. The crankcase itself was overbuilt. Massively overbuilt. Volkswagen had used the same basic case design from the tiny 1,100 cubic centimeters engines all the way up to the 1,600 cubic centimeters. The main bearing saddles were enormous. The case walls were thick magnesium alloy, cast with extra material. There was room inside. Room for a longer stroke crankshaft. If you could figure out how to make one. And that's when Carlos realized something that would change everything. Volkswagen hadn't hit the limits of their design. They just stopped looking. The Discovery and Stroker Crankshaft Revolution. Mexico City, November 1966. Carlos Gonzalez's home workshop, 11 p.m. on a Tuesday night. The fluorescent lights hum overhead as Carlos disassembles yet another VW engine, but this time he's not fixing it. He's measuring it. Obsessively. The stock VW crankshaft has a 69mm stroke. That means the connecting rod journals are offset 34.5mm from the main bearing centerline. Carlos pulls out his calipers and starts measuring the inside of the crankcase. The distance between the cylinder bores and the case walls. The clearance around the camshaft. The space near the oil pump. And then he does the math. He calculates, recalculates, and calculates again. His conclusion? You could increase that stroke to 82mm. A full 13mm longer. Without the connecting rods hitting the case. Combined with 92mm pistons and cylinders, this would yield 2,180 cubic centimeters of displacement. That's 36% more displacement than the stock 1600. More displacement means more air, more fuel, more combustion, more power. This could change everything. But there was one massive problem. Nobody made a stroker crankshaft for the VW Flat 4. Not in Germany. Not in America. Not anywhere. The aftermarket didn't believe it was possible. Volkswagen had said the case couldn't handle it. So nobody even tried. So Carlos made a decision that would define his legacy. If nobody will make it, I'll make it myself. He partnered with a local machine shop in Mexico City that specialized in agricultural equipment. Tractors. Harvesters. Industrial machinery. They had the tools, the lathes, the expertise in working with hardened steel. But designing a stroker crankshaft from scratch? That was something else entirely. The counterweights had to be completely reconfigured to clear the camshaft and oil pump. The rod journals needed special heat treatment to handle the increased leverage from the longer stroke. The entire crankshaft had to be balanced to within half a gram, or it would destroy the main bearings in minutes. It took 6 months. 14 prototypes. Carlos would install a crankshaft, run the engine, and watch it fail. Bearing failure. Harmonic vibration. Counterweight interference. Each failure taught him something. Each prototype got closer. On prototype number 14, February 1967, the engine ran. And it kept running. Smooth. Balanced. No vibration. No interference. Carlos had just done what Volkswagen said was impossible. But the crankshaft was only the beginning. Next came the cylinders and pistons. The stock VW cylinders were 85.5 mm bore with cast iron sleeves pressed into aluminum cooling fins. Carlos sourced raw cylinder castings and had them bored out to 92 mm. But here's what everyone else missed. Simply boring out cylinders wasn't enough. The cooling fin area had to increase proportionally, or the engine would melt. More displacement means more heat. More combustion means more thermal energy to dissipate. The stock cooling design couldn't handle it. So Carlos did something brilliant. He added extra cooling fins. 36 fins per cylinder instead of the stock 24. But he didn't just add more fins. He made each fin 2 mm deeper than stock. That increased the total surface area by 40%. 40% more aluminum exposed to airflow means 40% better heat dissipation. The pistons were forged aluminum, custom made to his specifications. The compression height was shortened by 6 mm to accommodate the longer stroke. The wrist pins were moved up into the oil control ring area, a modification that required custom piston rings from a racing supplier in California who thought Carlos was insane. The compression ratio was set at 8.5 to 1. Conservative by racing standards, but necessary. Mexican pump gas in the late 1960s averaged only 80 octane. Higher compression would cause detonation, and detonation destroys engines. But all of this, the stroker crank, the big bore cylinders, the extra cooling, all of it would be worthless if Carlos couldn't get air into the engine and exhaust out of it. And that's where the real genius was about to show itself. Because what Carlos was about to do to the cylinder heads would make Volkswagen's engineers question everything they thought they knew. The cylinder head genius. Mexico City, March 1967. Carlos Gonzalez stares at a bare VW cylinder head casting sitting on his workbench. It's 2 a.m. His wife has long since gone to bed, but Carlos can't sleep. He knows the stroker crank works. The big bore cylinders are ready. But none of it matters if he can't solve the airflow problem. And the numbers are brutal. The stock VW head flows about 65 cubic feet per minute of air at 0.500-inch valve lift. That's the standard measurement for cylinder head flow capacity. For comparison, a small block Chevy head from the same era flows about 185 cfm, almost 3 times more. Carlos knows that doubling the displacement won't mean anything if he can't get air in and exhaust out of the cylinders. An engine is just an air pump. The more air you can move through it, the more power it makes. Simple physics. But VW's heads were designed for economy, not performance. Small ports, small valves, minimal flow. Volkswagen never intended these engines to make serious power. But Carlos isn't bound by Volkswagen's intentions. He picks up his die grinder. For the next 4 months, Carlos will spend hundreds of hours reshaping these ports. The intake ports are opened from 28 mm to 35 mm. The exhaust ports go from 25 mm to 32 mm. But here's where most amateur engine builders make a fatal mistake. They think bigger is always better. It's not. If you just make ports bigger without understanding airflow dynamics, you actually hurt performance. The air velocity drops. Turbulence increases. The fuel mixture doesn't atomize properly. You lose power instead of gaining it. Carlos understands this. He's not just grinding metal randomly. He's reshaping the port floors and walls to maintain gas velocity while increasing volume. It's sculpture. It's art. It's science. Every curve matters. Every angle affects flow. The valve guides are narrowed from 11 mm to 8 mm to reduce obstruction in the port. The combustion chambers are reshaped to unshroud the valves, giving them room to breathe. And then come the valves themselves. Custom pieces that Carlos has to special order. Intake valves grow from 35.5 mm to 42 mm. Exhaust valves increase from 30 mm to 37.5 mm. These are massive valves for a Beetle engine. So massive they require custom valve seats machined from copper beryllium for better heat dissipation. Normal valve seats would crack under the thermal stress. The valve springs are dual units borrowed from a Porsche 911 and modified to fit the VW head. Spring pressure is 120 pounds on the seat, 280 pounds at full lift. That's enormous pressure. It has to be, to control those big valves at high RPM. Then comes the camshaft. Carlos designs a custom billet piece with specifications that would make any conservative engineer nervous. Lift is 0.560 inches on both intake and exhaust compared to 0.350 stock. Duration is 296 degrees at 0.050 inch lift. The lobe separation angle is 108 degrees, creating significant overlap. That overlap is what creates that characteristic lumpy idle. That race car sound. This cam requires solid lifters with 0.006 inch clearance that have to be adjusted every 500 miles. It's high maintenance, but it's high performance. But Carlos discovers something else. Something Volkswagen had been lying about, intentionally or not, for decades. The stock VW rocker arm ratio. Volkswagen claimed it was 1.1 to 1. But when Carlos actually measures it with precision instruments, he finds it's only 1.03 to 1. They were wrong. Or they were lying. By relocating the rocker shaft mounting points and using longer custom rocker arms, Carlos achieves a true 1.4 to 1 ratio. That means the cam's 0.560 inch lobe lift translates to 0.784 inch valve lift at the valve. That's extraordinary for any engine. For an air-cooled Volkswagen? It's unheard of. It's impossible. Except Carlos just made it possible. And now, with every component ready, it's time to see if Volkswagen's engineers were right. Time to see if this engine will make power or destroy itself. March 1969. The moment of truth has arrived. First fire-up and Volkswagen's humiliation. Mexico City, March 12, 1969, 6:45 a.m. Carlos Gonzalez's workshop. The first complete 2,300 cubic centimeters engine sits on the stand. Carlos had rounded up from the actual 2,180 cubic centimeters for marketing purposes. Every component has been checked 3 times. Torque specs verified. Clearances measured. Timing set perfectly. His hands are shaking slightly as he connects the final fuel line. 3 years of work comes down to this moment. Either this engine runs or Volkswagen was right all along. He primes the fuel system, sets the timing, takes a deep breath, and hits the starter. The engine turns over once, twice, 3 times. Then it catches. But the sound that comes out is nothing like a Beetle. Not even close. Instead of that characteristic put-put-put that every VW makes, this engine produces a deep, angry bark. A mechanical growl that rises to an absolute shriek as the RPMs climb. It sounds furious. It sounds alive. Carlos lets it warm up, watching every gauge like a hawk. Oil pressure. Cylinder head temperature. Climbing but stable. No smoke. No weird noises. No catastrophic failure. It's running. It's actually running. But running isn't enough. Carlos needs numbers. He needs proof. He'd borrowed an engine dyno from a diesel truck shop across town. It's crude, it's old, but it's accurate. He straps the engine down and starts the pull. First run, 168 horsepower at 6,800 revolutions per minute. Carlos stares at the gauge. That's almost triple the stock engine. But he knows there's more. For the next 3 months, Carlos tunes obsessively. Carburetor jetting. Ignition timing. Valve lash. Exhaust length. Every tiny change, tested and measured. And then, June 1969, he makes the final dyno pull. The engine screams to 7,200 revolutions per minute. The dyno gauge climbs. And stops at 203 horsepower. 203. With 176 pound-feet of torque at 5,500 revolutions per minute. Let that sink in for a moment. A stock 1,600 cubic centimeters Beetle engine makes 57 horsepower and 82 pound-feet of torque. Carlos Gonzalez's creation just made 4 times the horsepower and more than double the torque. From the same basic architecture. The same air-cooled flat-4 design. The same engine Volkswagen said couldn't reliably make more than 100 horsepower. Carlos just made 203. Naturally aspirated. On pump gas. And it didn't explode. It didn't overheat. It didn't destroy itself. Volkswagen was wrong. Completely, totally, embarrassingly wrong. But here's where the story gets even better. Because when word reached Wolfsburg, Germany about these Mexican Super Beetles, Volkswagen's reaction was exactly what you'd expect from a company that just got humiliated. Denial. Dismissal. Anger. Chief engineer Heinrich Nordhoff, the man who'd led VW's post-war resurrection, the engineering legend who'd made the Beetle a global phenomenon, he was furious. He sent a technical team to Mexico City immediately. 3 German engineers with diplomas from Stuttgart University. Men with decades of experience. Men who knew everything about the VW engine. Their mission? Prove this Mexican mechanic was lying. Prove the numbers were fake. Prove it was impossible. They arrived in August 1969. Inspected Carlos's engines. Measured everything. Took notes. Photographs. And then they wrote their report. The report was damning. Absolutely damning. The modifications violated every principle of air-cooled engine design. The cylinder head temperatures would exceed 450 degrees Fahrenheit. The crankcase would crack from the increased stroke leverage. The main bearings would fail within 1,000 miles. It was, they concluded with German certainty, technically impossible for such an engine to survive. The math didn't work. The physics didn't work. The metallurgy didn't work. Carlos Gonzalez was either lying about the dyno numbers, or these engines would fail catastrophically the moment someone actually tried to drive one. Volkswagen was about to publish this report. They were about to expose Carlos as a fraud to the entire automotive world. But Carlos made them an offer first. He invited the German engineers to witness a durability test. And what happened next would haunt Volkswagen for decades. The durability test and silent defeat. Mexico City, August 23, 1969, 7 a.m. Carlos Gonzalez stands next to a 1967 Beetle in front of Volkswagen de Mexico's main dealership. The 3 German engineers are there, notebooks ready, cameras ready, ready to document the failure they know is coming. Carlos had installed one of his 2,300 cubic centimeters engines in this completely stock-looking Beetle. The destination? Acapulco and back. 800 miles through mountain passes in summer heat. The German engineers follow in a chase vehicle with spare parts, ready to document the catastrophic failure they're certain is coming. Carlos fires up the Beetle and heads south. The first challenge comes quick. The climb out of Mexico City. Stock Beetles slow to 35 miles per hour on these grades, overheating, struggling. Carlos's Beetle maintains 75 miles per hour. Uphill. In 95-degree heat. The Germans are confused. This shouldn't be possible. Hours pass. They reach Acapulco. The engine is still running perfectly. The Germans insist on letting it cool before the return trip. They're sure the return climb will kill it. The next morning, Carlos heads back. The return climb is even more brutal. Higher altitude. Thinner air. The Beetle pulls the entire climb at 70 miles per hour without hesitation. They arrive back in Mexico City that evening. 800 miles. 2 days. Engine still running. The German engineers demand to tear it apart. They're certain there has to be damage. They disassemble the engine in Carlos's workshop. The results? Bearings showed normal wear. Cylinder head temperatures never exceeded 380 degrees, not the 450 they predicted. The crankcase was intact. No cracks. No damage. The engine was perfectly fine. The 3 German engineers packed their tools and left. Without comment. No apology. No admission. Nothing. Their report to Wolfsburg was never published. Volkswagen never spoke about Carlos Gonzalez publicly. They pretended it didn't happen. But the silence spoke louder than any words. Carlos had just humiliated Volkswagen's finest engineers. Word spread fast. Within weeks, Carlos's workshop had customers lined up. Racers. Enthusiasts. People who wanted the engine Volkswagen said couldn't exist. And the legend of La Cucaracha Negra was about to be born. Embarrassing muscle and forced induction. Mexico City, 1970. Carlos Gonzalez's reputation exploded. His workshop became a pilgrimage site. A complete 2,300 cubic centimeters stroker engine cost 45,000 pesos, about $3,600 US. Double the price of a new Beetle. Customers didn't care. They were buying victory. The most famous Gonzalez-powered Beetle belonged to racer Miguel Santana. His 1963 sedan was painted flat black with 0 exterior modifications. No hood scoop. No wide tires. Nothing. It looked like a grocery getter. The car became known as La Cucaracha Negra, the black cockroach. At the Autodromo Hermanos Rodriguez, that little black Beetle ran consistent 12.8-second quarter miles. Let me put that in perspective. A 1970 Plymouth Cuda 446 pack ran 13.5 seconds. A Boss 302 Mustang ran 14.3 seconds. America's premier muscle cars with massive V8s were getting destroyed by a stock-looking Beetle. Cars that cost 3 times as much. Engines 4 times the size. All beaten by a modified economy car from Mexico. But Carlos wasn't satisfied. In 1971, he began experimenting with forced induction. He adapted a GMC 2-71 supercharger from a diesel bus. Almost as big as the entire engine, mounted where the rear seat used to be. The engineering challenges were staggering. The stock crankcase ventilation couldn't handle boost. Carlos designed a dry sump oiling system. The carburetor mounting would crack under pressure. He fabricated a billet aluminum intake manifold. The fan shroud needed complete redesign. With 8 psi of boost, the engine produced 315 horsepower. 315. From a Volkswagen Beetle engine. More than a contemporary Corvette 350. More than a Porsche 911S. More than Volkswagen ever imagined possible. These blown engines required 110-octane race gas and rebuilds every 2,000 miles. But for drag racing? Unbeatable. A supercharged Gonzalez Beetle ran 10.9 seconds at 121 miles per hour. With the right gearing, 145 miles per hour in the half mile. Numbers that embarrassed supercars. And Volkswagen was watching. Furious. Because a Mexican mechanic was making their economy engine produce power that humiliated their entire engineering philosophy. They had to do something. And in 1972, they tried. Section 8. Legal Threat, Global Domination and Philosophy. Wolfsburg, Germany, January 1972. Volkswagen's legal department drafts a cease and desist letter to Carlos Gonzalez. It claims patent violations, reputation damage, demands he stop production immediately or face legal action. Carlos reads it, smiles, hands it to his lawyer. His lawyer's response is brilliant. Which patent specifically? The stroker crankshaft? Carlos's original design. The cylinder heads? Carlos's port work. The supercharger system? 0 VW parts. Volkswagen goes silent. Weeks pass. Then quietly, they drop the entire matter. No legal ground to stand on. By 1973, Carlos was shipping stroker kits worldwide. The first kit arrived in California in September 1973, ordered by Gene Berg, a legendary VW tuner who'd never exceeded 150 horsepower naturally aspirated in 15 years. Berg was skeptical. He assembled the kit with scientific precision and bolted it to his dyno. 198 horsepower at 7,100 revolutions per minute. Berg immediately ordered 10 more kits. Within 1 year, Gonzalez stroker engines dominated West Coast VW drag racing. The old guard had been overthrown by a Mexican dealer mechanic. But here's the most remarkable part. Carlos never patented his designs. When asked why, his answer was simple: knowledge should be free. If Volkswagen had shared their engineering freely, I wouldn't have needed to figure this out myself. By 1975, American companies were producing stroker cranks based entirely on Gonzalez's specifications. The 82mm stroke became the industry standard, and Carlos celebrated it. Because the VW performance industry, now worth hundreds of millions annually, exists because one man refused to accept impossible and refused to hoard knowledge. But the impact was about to go even further. Because Porsche was watching, and they were taking notes. The Ripple Effect and Porsche Connection. California, 1975. American companies were manufacturing stroker crankshafts, all based on Carlos's specs. The 82mm stroke became the foundation of every serious VW build. The performance industry generating hundreds of millions annually? It traces back to Carlos proving it was possible. But Porsche engineers in Stuttgart were paying attention. Uncomfortably. The 911 used a flat six with similar air cooling principles. Porsche had always dismissed the Beetle engine as primitive. But now this Mexican mechanic was making 200 horsepower from that primitive design. Several Gonzalez innovations started appearing in later Porsche engines. Deeper cooling fins. Revised rocker geometry. Port floor modifications. Officially, Porsche never acknowledged it. But in 1998, former engineer Hans Mesger admitted, the Mexican modifications showed us possibilities we hadn't considered. Carlos kept evolving. Mark II heads in 1976, 145 CFM flow. Mark III in 1978, bronze guides, sodium-filled valves. Mark V in 1981, CNC chambers, 165 CFM. Small block Chevy Territory. From an air-cooled Volkswagen. In 1977, Carlos partnered with Scat Enterprises. Forged chromoly cranks, computer-balanced, safe to 8,500 revolutions per minute. But the most unexpected validation came in 1979. From an industry where engine failure means falling from the sky. An aircraft builder named William Wynn wanted Carlos's engine for his plane. What happened next proved Carlos's engines weren't just fast. They were bulletproof. Aircraft revolution and twin-engine madness. Lakeland, Florida, March 1979. William Wynn needed an engine for his home-built aircraft. Certified engines cost $15,000 to $25,000. Stock VW conversions overheated and struggled. Then he read about Carlos Gonzalez. Carlos developed a special aircraft version. 7.5:1 compression for aviation gas. Milder cam, hydraulic lifters. Dual ignition, 2 plugs per cylinder. Deep sump holding 8 quarts. Every component magnafluxed. Derated to 125 horsepower at 3,600 revolutions per minute for reliability. Wynn's plane flew Florida to Alaska and back. 8,000 miles. Only oil changes needed. The FAA refused certification, but for experimental aircraft, the 2,300 cubic centimeters stroker became gold standard. Today, hundreds fly with Gonzalez engines. Millions of flight hours. Safety record matching certified engines. But racing got insane. 1982, Colombia. Juan Pablo Montoya Sr. built a twin-engine Beetle dragster. 2 supercharged Gonzalez engines. Crankshafts phased 180 degrees apart. For fuel pumps. 8 Weber carbs. Total output, 640 horsepower. The car ran 8.7 seconds at 154 miles per hour. World's quickest Volkswagen. That record still stands. Cylinder temps hit 425 degrees. Rebuilds every 20 passes. But nobody cared. A Beetle just ran 8.7 seconds. And Volkswagen was watching everything. The racing victories. The aircraft flying. The worldwide adoption. And finally, they made a decision that admitted everything. They were wrong. And Carlos was right. 1983 Carlos developed a mild 2,100 cubic centimeters street version. 110 HP, 100,000 mile reliability. VW Mexico secretly recommended them. Mexibug performance, 42 employees, 120 million pesos annually. 500 engines, 2,000 kits yearly. National Prize for Technological Innovation. Then 1986. After years denying his work, Volkswagen hired Carlos as consultant. Brought him to Wolfsburg. Official title, Special Advisor. Real job, teaching German engineers their own design. His lessons influenced the Wasserboxer engine. VW never publicly acknowledged him. But Carlos won. He humiliated them. Forced them to hire him. To learn from him. The dealer mechanic beat Germany's finest. Carlos proved engineering limits are self-imposed. VW said 350 degrees Fahrenheit max. He ran 425 degrees Fahrenheit for hours. They said 69 mm stroke max. He ran 82 mm plus. Modern VW engines, 3.0 L, 1,000 plus HP with turbos. Aircraft, 150 HP, thousands flying daily. La Cucaracha Negra sold for $340,000 in 2018. Carlos today at 91 still consults. His greatest achievement? Letters from worldwide builders. Knowledge multiplied beyond patents. 3 lessons: limits are guidelines, innovation needs curiosity, sharing multiplies impact. Carlos didn't just outsmart VW. He demolished engineering authority myths. Proved innovation belongs to innovators, not institutions. The only real limit is the one you accept. Drop your impossible story below. Subscribe for more automotive rebels. Innovation doesn't ask permission.